Welcome everyone. Today we are going to learn the drawing of profile and geological cross section for this particular map. We have to draw the cross section along line AB in this map. So let's first interpret the map. We can see that there are 6 marked indexes in this particular map. So here what we are seeing in the map are first is contour lines. So what are the values of contour lines? We can see that the value of contour line, they are varying from 400 feet to 900 feet. So the minimum elevation of this area is more than 300 feet but less than 400 feet, and the maximum elevation of the area is over here, that is more than 900 feet but less than 1000 feet. So this was about the topography. We can see that there are, because we are getting oval shaped contours over here and here, so there are 2 hills that are separated by a valley in this region. So the hill is towards northeast and also towards the southwest, and here the maximum height of the hill is in between 1000 feet and 900 feet, and in this region the hill is between 900 and 800 feet. So let's see what are the structures which are present after the topography. We can see that there are some beds like this, and this. The traces of these beds are truncated against this trace, and of course along this trace as well. So if a number of beds are truncated against a single trace, that trace represents a trace of unconformity. So this is trace of unconformity. We always mark unconformity with zigzag lines. So if there is one unconformity in any area, this represents that there are 2 sequences. Now after marking the unconformity, we will identify that which trace is younger, or which sequence is younger and which sequence is older. So the sequence which gets truncated is older in nature, and the one which truncates is unconformity surface, and the one parallel to the unconformity surface are the younger sequence. So these beds are being truncated. It means these are representing the beds of older sequence. So how many beds are there in the older sequence? 1, 2, 3 and 4. How many younger sequence are there in the How many beds are there in the younger sequence? 1 and 2. 1 and 2. So well, there are 4 beds in older sequence and there are 2 beds in younger sequence. Apart from that, we can also see a cyclic repetition along a straight line over here and a straight line over here. So if any feature is present that is vertical in subsurface, that makes a straight line trace on the ground. So these 2 traces are representing the fault. We can again see that this fault is not truncating or not disturbing the unconformity. It means when this fault was formed, unconformity was not there. It means this fault is pre-unconformity fault. But if we see this fault, this is affecting our older sequence as well as younger sequence and shifting the unconformity as well. So this simply means that these this fault is post unconformity fault. That is, this is the youngest feature in this particular area. This has been developed after the development of older sequence and younger sequence. This faulting has been taken place. So this is a pre-unconformity fault, this is a post-unconformity. So overall, we have two sequences in this particular area that are separated by an angular unconformity, and also there is presence of two fault. One fault is pre-unconformity fault, another fault is post-unconformity fault. Now let's see that which bed is younger and which bed is older in older sequence. So we will have to draw two strike lines in order to determine the younging direction in any sequence. So let's take 2 points on a same trace which is intersected by same value of strike line. So one strike line is this one. The value of this strike line is 700. And the value of this strike line, this line should always be parallel to the earlier strike line. So in order to draw that, what we need to do is we are going to take a protractor and see if the movement is parallel or not. So here is our trace. Now let's draw this strike line as well. So the value of this strike line is 600 feet. So if we got two strike lines which are of successive values, so from higher value of a strike line to lower value of a strike line, we have direction of tip. It means this is the direction of tip. This is tip direction. The top of map always represents the north, so this is the north, and the scale in this map as well is 1 inch is equals to 1000 feet. The CI is 100 feet. Well, so we can now determine that younger beds of older sequence are occurring in this direction. So opposite to that, this will be oldest bed. So this will be bed number 1. This will be bed number 2. The yellow one are representing bed number 3. In fact, the yellow ones are the mudstone. These are conglomerates of Silurian age. And these are grids. These are mudstones. And the fourth one are Silurian shale. So this is bed number 4. That is our Silurian shale. This is 3. This is 2 again. So this is 2 and this is 3 and this is 4. And this one is bed number 1. So this should also be colored with blue color. So now we have identified the younging in the older sequence, and of course in the younger sequence the bed which is in contact with unconformity is bed number 1st, and the one which is just immediate is bed number 2nd. So this is bed 1st and this is 2nd. This is 2nd. This is at first of the younger sequence. So here in Silurian we have deposition of the older sequence, that is our conglomerate, grit, mudstone and Silurian shale. Then there is upliftment and faulting in the area, so there is development of a pre-unconformity fault. Then this upliftment was for significant time and it led to erosion in older sequence of rocks and developed an angular plane in relation to the older beds, and that plane at that time was almost horizontal, and this was an unconformity plane. So this unconformity was also developed after the fault. Then the area was subducted back again into the Carboniferous, and there was deposition of limestones. This is represented by wet first in white color, and then it was followed by deposition of Carboniferous sandstone. The area was again uplifted, tilted, and it was faulted by this particular fault. So it affected all the sequence because this is the youngest feature. This fault is youngest feature in this particular area, so it affected the older sequence as well as younger sequence. And then the area was eroded to form the present day landscape. So this is all about the interpretation of this map. Now let's draw this map. So in order to draw the map, we need to know the dip amount and dip direction. We have already determined the dip direction for the older sequence, but we have to know about the dip direction of younger sequence as well. So that can be known by drawing two strike lines for unconformity as well. So this is the same unconformity which is intersecting over here and here. We can draw a line in this direction. So this is one strike line for unconformity. The value of this strike line is of course 600. This is for the younger sequence as well as unconformity. The another line is parallel to this line, this direction. So let's draw that line as well. The next strike line should be of either higher value or lower value. Then this 600 strike line which we have already drawn. Let's move it. So here is one more 700 value contour line which is intersecting the unconformity. So we have second strike line over here. The value of this is 700. So yeah, the younging direction is this direction from B to A. So if we need to know the amount of dip, what we will have to do, we will have to measure these distances of HE, and then we'll have to draw the CI over HE and come to know about the dip amounts in our section line. So we always measure the HE in section line because that is our angle of interest. We are going to slice out this area along AB. So we'll have to take horizontal equivalent in that direction only. So let's plot this horizontal equivalent over here. These are 2 points. Let's plot this. pencil. And draw 0.1 inches over it. This is 0.1 inch. Now we can make, or rather if we draw over here, we can join these 2 points. Either we can go in this direction or in this direction, because I have drawn this line in this direction, so it will be easier to measure the angle from here. So this is our dip amount of older sequence. Let's measure it. This is roughly 7 degrees. Now let's determine the dip amount of younger sequence. So we need to measure the HE for younger sequence. So this is HE for younger sequence. Let's plot this. Now again do the same exercise. Join these 2 points. This is going to represent the HE, and then plot CI 0.1 inch. And now join these 2 points. So if we measure this value, this is going to give us the dip amount for younger sequence, and here we can see the dip amount for younger sequence is roughly 3 to 4 degrees. So younger sequence beds are less dipping and older sequence beds are dipping with more amount. So we have determined the dip amount as well. Now we need to plot our beds. For that, either we can make a strip or fold this map and then draw the section line. So this is A and this is B. What we first need to do is draw the baseline for AB. This point is A. This point is B. This is the fault, which is pre-unconformity fault. So I am writing F for here. And then we are also going to mark the traces of beds and the values of contour. So here is one bed. I'm going to write V for this. Here one more bed. This is one more bed we are getting over here. And these are the values of contours. So the value of this contour is 400. I'm drawing it. Here we have 500, and here and here. And then we are getting one contour over here as well. This is 500. This value, it's 600. This point and this point, this is 600. Now let's join these lines. So here we have baseline AB. Since the values of contour is varying between 400 to 1000 or 900, we can draw up to 1000. That will be sufficient. So here is 0.1 inch, 0.2 is 200 feet, 0.3 is 300 feet, 400 feet, 500, 600, 7, 8, 9 and 10. This is representing the 1000 in this direction as well. This point represents the 1000 feet, 900, 800, 700, 600, 500, 400, 300, 200, 100 feet. So this is 100, 300, 500 feet, 700 feet, 900 feet, and in this direction we are going to mark the even values: 200, 400, 600, 800, 1000. Of course 0 feet. Then we need to mark the fault, and fault is vertical in nature, so we simply need to mark it like this. Above the profile we will remove, below the profile it can extend. Then we need to mark the contour values. So here is 400 value, then we got 500, here this is 500, so here we have height of 500, and then we have 600 at 2 points, 500 and 600 here and 600 here. And then we have 500, one more 500 over here. You can draw this point. Then if we observe carefully, the value is decreasing in this direction A, and here, and this is 600, this is 500, so next one is 400. This is decreasing in this direction as well. So if we join these points smoothly, this will start between 300 and 400 like this. And this is 600, this is 500, so this will go like this. And then between 500 and 400, this will join somewhere like this. So this is our profile. And then we need to draw our beds. So let's see that where we have got the beds. So first bed is over here of the older sequence, so we need to project it. And then second we have got at this point, So we will project the second bed as well. So here is our second bed, here is our first bed, and we have got one more trace of bed over here. Now let's see that how to plot them. So we have already determined the dip amount for younger bed, and that is 7 degree, and direction of it dip is from A to B. Let's plot 7 degree value onto the base of this baseline. So this line is going to represent the dip amount for the beds. Now let's plot the beds. And the beds are going to plot parallel to this 7 degree. So here we have got our one bed. This is not going to extend beyond the fault because fault has affected them. This is our second bed. So this is representing the bed number 1, and bed number 1 is in fact the conglomerate bed that is in general deposited over any unconformity. And then we have second bed is grit bed, so this is the grit bed, and third bed is our mud stone, so this represents the mud stone. Now we are getting the bed 4 over here, and this is again parallel to these beds. So let's plot that as well. So we are getting just a pinch of, or you can say silver of bed number 4. So here is our bed number 4. And this is the lower face of bed number 4. Below that we have bed number, upper trace of bed number 4, so this is 4, and now above that we have bed number 3. So this is bed 1, this is 2. Now we need to draw the upper trace of bed number 4 over here, or lower trace of bed number 4 over here. So in order to do that, we need to know the throw. So how we can determine the throw in this map? So throw can be determined by knowing the positions of the traces or same trace in one block and another block. So here we can see that this trace is lying at 500, and another block it is lying near to 600. Now let's see this one. Here it is lying at 600, And here we see this trace by drawing the continuous lines. So the value of this line will be 800. And here this is intersecting the 600. Let's try to determine the thickness of this bed. So here it's 700. This is 600, this is 700. If we draw the next one parallel to this, this will be 6, 7, this will be 800. So if we see over here, this 800 is intersecting the 600, it means the thickness of bed 3 will be 200 feet. So we can easily determine the thickness of bed 3, and that will help us to determine the lower trace for bed number 4. So this one is in fact 6, 7, 800, and it is intersecting the 600. So there is difference of 200, means bed 3 is our 200 feet thick. So this is bed 1, this is 2, this is 3. So 3 will be 200 feet. If we draw it over here, the vertical thickness for bed 3 is 200. So it is just above the profile line, somewhere here. Now bed 4. So if we know the throw, that will give us the position of bed number 4. So here will be our line must be parallel to this line. As we have determined already that our throw is 100 feet. So if we draw this trace just below the 100 feet over here, we'll get the position of this trace. So this is our bed 1 in this area. Bed 2 will be here. Just this equal thickness will represent the bed 2. And here we have bed number 3. Then we have bench of bed number 4 over here. So we can see that this is down thrown block and this is up thrown block because the younger beds are coming at lower height in this region. So now let's darken the profile. Through is 100 feet as this trace over here is present on 500 and this is present over 600. So we got to know about the throw by knowing the position of traces in two different blocks. So if one block same trace is present is 500, in another block it is present at 600, it means there is a difference of vertical difference of 100 feet. So throw is 100 feet. This is profile. Now once we have drawn it, we can darken the profile. So here is our bed number 4. This is 4. This is bed number 3. The thickness of bed number 3 is 200 feet. So we have just projected it over here and we have drawn 0.2 inches below this because this represents the bed number 4. So below that will be bed number 3. So 200 feet over here will be, this is bed number 3. And then we have bed number 2 here. This is bed number 2. Here we have bed number 3, then we have bed number 2. We have bed number 1. Now let's darken this line as well. This is our fault. Above the profile, this will be represented by dissected lines. So we have determined the down throw direction as well. This is our down throw direction in this area. So if we see the younger beds are coming in contact with the older bed of this block, this means this is down throw, and here we can see this is down throw. This block is up throw. Now we can give different colors over here. So we have conglomerate this region, and that is represented by the dots. And this is our bed number 1st. It is represented by green color. So this is conglomerate. Now let's first remove pencil. Let's put down the colors. The base for bed number 1 is not known, so that will be unconfirmable. So bed number first for any sequence, it always deposits over unconfirmable basement. In this area as well, this is first, this is second, this is third, and above we have so here we have conglomerate. And this is of Silurianase. Then conglomerate was deposited unconfirmably, followed by conformable deposition of grits. So we have grits. And that is represented by a red symbol. So here we have bed number 2 is grit. The bed number 2 is exposed in this block for this distance. This is bed 2, this is the bed number 1, and this is 2 1, this is 2, this is 3. So bed number 3 is represented by yellow color and fine dots. And the 3 is in fact mudstone. So here we have mudstone. Now let's put the color. This is mudstone. And then we have bed number 4, that is our Silurian shale, and that is represented by brown color. So mudstone was represented by in fact yellow color. Fill the wrong color over here. We can fill the yellow color by removing first the brown color. The fourth is in fact brown color. So here you can fill mudstone symbol, and that is the yellow one. So this is mudstone, Silurianase. Then we have the fourth bed over here, and that is our Silurian shale. The fourth one is Silurian shale. So this is the cross section. Now we can see that younger sequence is not coming over this particular cross section, so we can take another directions in order to get the younger sequence. Let's say this one, and we can draw the cross section along this direction. So now we will get the younger sequence as well. So we will be drawing the cross section along this direction in another class. So today we have completed this map, the cross section of the map along this line AB. And for this map we have got the profile like this. So this is the fault and these are different bits. So this is limestone, this one is conglomerate, grit, mudstone and Silurian shale. So bed first is conglomerate, this is grit, this is mudstone, and Silurian shale is present in this block. Here we are not getting in this block on our section line. So now we have completed this map. We can make the symbols as well. The first is our conglomerate. Then we have grit. Grit is represented by red color symbol. Then we have mudstone. And ultimately we have the Silurian shale that is represented by brown color symbols. Silurian sequence. Right. Then we have two more sequences, limestone and sandstone. In fact, two more beds of one younger sequence, that are the limestones, which have not given any symbol, and then we have sandstone that have been given a symbol. So this is limestone and this is sandstone. This is of Carboniferous age. This is younger sequence. So we are not getting the younger sequence over this section line, so it is not coming over here in our section. So this is geological, cross section, along AB. Right. So this is the map and this is cross section. Now let's interpret the geological history. So bed first of the older sequence, that is our conglomerate, the Silurian conglomerate was first deposited unconformably over unknown basement, followed by the conformable deposition of grit, mudstone and Silurian shale. Then the area was uplifted, tilted and faulted, and it was exposed for significant time, so that led to development of an angular unconformity in the area. Then the area was again submerged into the Carboniferous and deposition of limestone took place unconformably over angular unconformity. Then this was followed by conformable deposition of sandstone of younger sequence. Then area was again uplifted, tilted and faulted. So there is one more fault that is affecting the older sequence as well as younger sequence, and this is our post unconformity fault. And the erosion took place in the area, so that gave rise to present day landscape. So this is the map and this is our section line. And structures, what are the structures present in this area? So structures, if we analyze, we have two sequences separated by an angular unconformity, and the older sequence contains 4 bits and younger sequence contains 2 bits. And there are two faults, which one is pre-unconformity fault and another is post-unconformity fault. So thank you everyone. In the next class we will learn some more maps and we will draw more section line in this map as well. Thank you.